Hello, this is a review on multiplying radicals. So just a few things you need to know is that if the radicals have the same index, that is, they're both square roots or they're both cube roots or both fourth roots, then you can multiply them. In this case, the first one, it's square root of 6 times square root 2. You just simply multiply them. This would be square root 12. Now you'll notice that square root of 6 and square root of 2, neither of those have a perfect square as a factor of them, but when you multiply them, you get 12, and that does have a square root factor, a perfect square factor. So you would change 12 into the square root of 4 and the square root 3. And then as before, you can take the square root of 4, that's 2, and square root of 3 has to stay the same. So there's really just one step. You do the multiplication, and then you see if there's a perfect square inside of your product. So try this guy. Again, there's a 2 out front that is not part of the radical. It's being multiplied by square root 8 and then multiplied by square root 3. So multiply your two radicals together. The 2 cannot be part of that because it's not a radical. So the 2 will stay out front, and then 8 times 3 is 24. And there is a radical in 24, it's 4. So we could take that out. So then this would be 2 out front, square root 4, square root 6, and then we simplify the 4 to a 2, and as before, we can multiply the two numbers that are out front that are not radicals. So this would be 4 root 6. All right, pause for a second. So we could have, off the bat, we could have decided to change the 8 right away because that has a perfect square in it. And here's what would have happened if we would have done that. We had 2 root 8 times root 3. 8 is 4 and 2. And then the 4 is a perfect square, it's 2. So 2 times 2, that's going to be 4. And these guys, the square root of 2 and square root of 3, nothing can happen with them, but they can be multiplied together because they're both radicals. So if you multiply those, you get square root of 6, and then we end up with the same answer. So you have some options on this. You can either decide to multiply first, like we did here, or you can decide to break down anything that can be broken down at the beginning, and then multiply the numbers that can be multiplied together. Sometimes there are benefits to doing one way over the other, but either way, if you just pick one of the methods, it will work out either way, as long as you can continue to find the perfect squares that are a factor of the number you're trying to reduce. This guy's a little bit different. It has variables, but we're used to that now, so I'm just going to straight up multiply these guys together. That gives a square root 36, because that's 3 times 12, and then x times x to the third gives 4 x's, or x to the fourth. And as you remember before, the number you want to try and reduce if you can, and 36 is a perfect square, so we don't need to take anything out of it. We don't need to figure out what two numbers multiply to be it, because 36 is a perfect square. It's just 6. X to the fourth, remember, for square roots, we want to chunk everything in groups of 2. So this would be square root x squared and square root x squared. And then we've used all of the 4. 2 and 2 is 4. So the square root bar and the square cancel each other out. Square root and the square cancel each other out, and we're just left with x and x. So this is really 6 x squared. All right, hang in there, last one. Same situation going on. You have a 12 and a 6. We could multiply them all together. This gives you a 72, x to the 8th. And 72 has a perfect square inside of it. It's 36 is the largest one. That's the one you want to use. So square root 36, square root 2. And then there's 8 x's. We want to chunk them in groups of 2. So that's square root x squared, square root x squared, square root x squared, and square root x squared. 36 square root of 36 becomes 6. Square root of 2 is stuck, so we'll save that for a second. And then square root of x squared, 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 they all just become single x's. And they're all being multiplied together, as all of this is. So that's 6x to the 4th now, but we still have the square root of 2. That could not come out of the square root bar. So our new simplified answer is 6x to the 4th square root of 2. So again, remember, it may be beneficial at times if you have really large numbers already before you multiply, like, square root 18 and square root 54. You may not want to multiply them together right away because you'll get a large number. If you break them up first, this is square root of 9, square root of 2, and then 54 also has a 9 in it. It's square root 9 and square root 6. So we'd have 3 square root 2, 3 square root 6. But we have to combine the things that can be combined. Whole numbers multiply to be whole numbers. I mean numbers outside radicals. So that's a 9. And now the two radicals be multiplied together. Square root 12. And then there is still a problem here because now we have a new product, 12, that also now has a perfect square in it. So this would be square root 4, square root 3. 9 is still there. So it's 9 times 2 square root 3, or 18 root 3. It seemed like extra work, but if you multiplied 18 and 54 together, you end up with square root 972. And that's a large number. You may be guessing on what the largest square root, largest perfect square factor of 972 is. And so you might be guessing a while. So I personally would rather do this amount of work than guessing and checking on the 972. But depends on your preference. Either way will work. All right. Happy simplifying.